Hello and welcome to Computer Tech and More. Today we're going to be taking a look at the Iceberg Thermal IceGale Xtra 120mm fan. Let's hop right into those graphs and then we'll do our open box experience. Here is the raw data for the IceGale Xtra 120. It is a pretty much bog standard 120mm fan. It's 25mm thick, dual ball bearing, 12 volts, and 0.54 amps. That is an incredibly high amperage. I'm going to repeat this a couple times throughout the video, I believe. And that is one fan per fan header. Maybe if you're lucky two, but any more than that, you're likely to blow out a circuit on your motherboard. It is just not designed for a fan of that amperage. Most other computer case fans are drawing decimal point 5 amps. So that is an incredibly high amperage for this fan. I just don't know what else to say about it. It's just incredibly high power draw. You may even find limitations with a powered hub for fans. But its speed range is 500 to 3000 RPM. Airflow is rated at 127 CFM maximum. Static pressure 4.6. Decibel rating 40. That is really high. 6-year warranty, and mean time between failure was at 160,000 hours. Okay, first up is my case simulation test. So in the case simulation test, there are a couple different ways of looking at it. So first up is how the fan dissipates air. So in an ideal world, the most perfect fan, in my opinion, ever would basically blast air in a perfectly straight line in a basically tube shape or behind the fan. So there would be no air velocity loss from the beginning to the end. It would just be perfectly flat at whatever air velocity it was able to achieve. However, we don't live in the perfect world, and there are aerodynamic losses because the fan has to push air out of its way to basically blow air. That's how a fan works. So you're going to see a loss. So the best fan for case airflow would be one that has as slow a drop as possible. Larger fans, so 140 plus, tend to do better in this application overall. So 120s have a harder time doing it. They're smaller, and even smaller than that have an even harder time. But you still want it as flat as possible, and you want it as linear as possible. You don't want to see a start drop off or steep drop off in the other direction. It just indicates that the fan is shooting air off to the sides and not really down your case. The second way of using this data is with the case simulation, basically. So the case simulates a case that can hold up to 180mm size fan, roughly based off of the fractal design torrent in terms of its width. So it's got a 6-inch, a 9-inch, an 11, and a 14.5-inch. And those are representative of different size cases. So a 6-inch would be representative of a small form factor type case that still is pushing air through every direction, but small form factors tend to need more pressure-oriented type fans. 9 inches represents a small form factor case that more or less is a standard case layout, front to back type airflow. 11 inches is representative of a mid-tower. I use the distance mark from my Corsair 550D, but the fractal design Meshify 2C, I believe, would also fit into that category, while 14.5 inches is very representative of the fractal design torrent, a large full tower type case. So once again, you want as much airspeed left for wherever you get to your fan. So if you have a mid-tower case, you're looking at this. If you have a smaller case, you're looking at this. If you have a big full tower, you're looking over there. So it's just how you want the maximum amount of airspeed possible for when the air hits your fan. And if you have an AIO or other liquid cooling options, you still want air velocity going through it, but it matters a little bit less. The equation changes a little bit. But that data doesn't mean anything unless we have something to compare it against. So I have a standardized control fan here in this blue line. The control fan is based off of the A12X25, 3 parts A12X25 to 1 part Noctua A14. Two fans that I consider very good in their respective categories. The A14 is mixed in there because again, the 140 millimeter size fans tend to do a little bit better at airspeed towards the end. So I wanted to have something in there to help it out at the 14.5 inch mark, even though I'm giving up a little bit of airspeed at the 6 inch mark. So the IceGale Xtra performs kind of badly overall. So it kind of doesn't move a lot of air, and then it actually stays pretty level, and then it drops off pretty heavily. So this kind of tells me that it creates a relatively good funnel pushing shape down the case, but kind of then spreads out a bit more rapidly. Overall, it's not a bad result. And my noise normalized value is based off of the A12X25 at around 1,200 RPM, which in my old case, the Corsair 550D, and using it in an AIO, I found that RPM equated to a fairly silent experience, where I just heard a little whooshing sound coming out of the fans. So I considered that to be fairly quiet, or very quiet actually. It was very minor noise. So that's why I could use that as my noise normalized value. How do things look at 100% PWM fan signaling? Well, it's no surprise. This is a 3,000 RPM fan versus a 2,100 RPM fan. So the control fan is just completely blown away. But you can see it has a very steep drop-off in performance as compared to the control fan. Next, how does this fan compare to other ones I've tested? Well, off the charts is the General Typhoon. It would just completely mess up the scaling on this. At the top of the graph, we have like the Tough Fan 12 and the Silewings 4 Pro, the A12X25, and like the Wonder Snail. Down here at the bottom, we have like the P12 and the Noctua S12B. So the IceGale, Iceberg, whatever you want to call it, Thermal Xtra performs kind of between the top and the bottom. I would say it's an average result. It's not great, but it's kind of middle of the road, so not much to write home about. Boosting things up to 100% PWM fan signaling, and we can clearly see that this is a really quite good fan at pushing air. It is outperforming the P12 Max, especially at the 6 inch mark, but it kind of loses ground here at the end. And in the middle, at the 11 inch mark, it's basically right there in the running with the top fans, but at the 9 inch mark, it's still number one for all intensive purposes. The General Typhoon is basically middle of the road, and many of the other fans are kind of positioned more or less where you would expect them, considering their RPMs. Over here at the Legend, you have the RPM and the noise rating for each and every of the fans tested. And it's worth noting that the IceGale was at 64 decibels. As a note about decibel readings, every 10 decibels is a doubling in its magnitude. So the General Typhoon at 43 versus 64, the IceGale Xtra is substantially louder than it. So you need to keep that in mind depending on how you're using this fan. Taking a look at the data from another perspective, this is at the 9 inch case mark, so it's kind of halfway between where the fans that don't fling the air in every direction do really well, and at the 11 inch mark is where the fans that tend to blow the air in every direction tend to really drop off. So we took the middle ground at 9 inches, and we see that the Iceberg IceGale Xtra is sitting right here in this purple line, and it's kind of below the main pack of better fans, not at the best, but better fans, but below the worst fans. So overall, it's kind of okay, actually, up to like 40% PWM fan signaling. I need to note over here, the fan for me would not work in Windows, period. So I had to actually use the fan in BIOS only. And for whatever reason, the fan was not working at 20% PWM fan signal, so it kind of makes the data wonky over here because it's actually going to 0. But in the end, you can look at these two data points, and it's creating a fairly linear looking line. And of course, after it's at 30, 40, and then it just propels up and gains a lot of air velocity for not that much difference in noise value. But at that point, the fan is already so noisy that it's really not worth considering, in my opinion. IceGale full config. Next up, we're taking a look at the performance of this fan through my CPU AirCooler. It's a U12A from Noctua. And in these graphs, better fans are in the top left, worse fans are in the bottom right. The first one is RPM, horizontal, vertical is airspeed, and in the right graph, it's airspeed vertical and noise level horizontal. So first and foremost, let's look at RPM versus airspeed. We can see that the fan, the Iceberg Xtra, is a very high performing fan for its blade design. So this is basically a blade efficiency test, and it performs quite well at its entire RPM range. It is outperforming my control fan hands down. However, when we take a look at its noise profile, well, it's just flat out noisier. Again, my one random data point, just right there. So it's hard to know exactly where it should be lying, but its starting off point is already so noisy. But it technically beats my control fan in its positioning, but I just think it's so noisy at that point. Again, hard to consider this fan. Next is noise normalized values. So the Iceberg Xtra would be spinning at around 800 RPM to achieve its noise level, and this was more or less done by estimation because, again, I couldn't achieve its lower RPMs, so I had to kind of finagle it a little bit and estimate the value. So it's not done at 100% confidence. And another point I need to make about this is that in airspeed testing, my anemometer is accurate to within 0.1 meters per second. So that's plus or minus 0.1. So fans that are within 0.1 meters per second should be considered functionally equivalent. Other notable notes about this graph. You'll see this number, wattage, W, equals a number next to it, and that is an airspeed. In another video, I did extensive testing on what airspeed equates to what wattage in my CPU. And this is for my specific AirCooler, the U12A, and my specific CPU, the i7-11700K. And even if you have the same cooler and same CPU as me, you may find slight differences due to standard variation within the parts. So if you have the same cooler as me, but a different CPU, you may find the wattages don't quite line up. And if you're using a different cooler than me, even with or without the same CPU, how can you use this data anyways? Well, if let's say you have the NF-F12 hooked up to your CPU cooler and you're looking at noise normalized values, you're getting 0.7 meters per second of air. Well, let's say you increase that, you went up to the Ventral Pro, which is the same as the Gentle Typhoon. Well, now you're getting 2.1 meters per second of airflow. That is a huge improvement. So instead of, let's say you're using the same cooler as me, you're getting 145 watts on your cooler. Now you're able to get 225 at the same noise level. Or if you think my noise level is still too noisy for you, you can dial it back to a slower RPM, and now you're getting less noise for the same performance. Do note that not every cooler radiator is the same. So some respond better to better pressure. So denser fin stacks respond better to pressure, while looser fin stacks respond better to airflow. And at some point, there are diminishing returns for coolers, radiators, for the amount of air you're pushing through it, for how much more heat is being able to dissipate. So do know that it's basically not a linear line, it's a quadratic line for wattage improvements for air velocities. Now, how do things look at 100% PWM fan signaling? Well, they're looking pretty good for the Iceberg Thermal Xtra. It's got a long name. Spinning at 3,000 RPM, 64 decibels, it's pushing 3.4 meters per second of air. It's beating the T30, mind, at more noise. It's beating out the Noctua PPC 3000 RPM F12, but the Noctua is also noisier. Woo! The Mobius OC and the SilentLynx 4 Pro, it's just crushing everybody, but at the price of incredibly loud noise. And you can clearly see where other fans lie on this graph. Next up, we have, still through the CPU cooler, but airspeed versus noise. Airspeed is the vertical, noise is the horizontal. Better fans sit in the top left once again. And here in this one, the Iceberg Xtra is sitting in the screen line. Again, I don't have that data point, so it's hard to know exactly what's going on in it. But here it looks like it sort of is performing okay, and then it drops further back, and it drops further back some more, and then it kind of gains. This blue line is the T30, so it ends up being a similar level of performance to noise as the T30. It just seems to have a slightly more efficient blade at the end to achieve this higher performance, but I'd say it's functionally equivalent. But it is doing substantially better than like the Noctua F12 3000 RPM version. Changing gears to my third and final main test platform, and that is the the CFM testing. So CFM is sort of this very scientific number. To calculate CFM, you're literally blowing air down a known surface area. And you know how much air you're pushing, so that's meters per second, and you know the area, so you're able to calculate volume per time, which is CFM, cubic feet per minute in this case. And it's basically scientific. You're blowing air down a tube, and the tube completely negates, or mostly negates, the effects of the air being shot out to the sides. So in general, the data is going to show that fans perform more similarly. Mind, a fan that is not very good at pushing air straight and blows it out to the side will not perform as well as one that is better at pushing the air straight. But it tends to hide the fact that the fan is blowing it off to the sides and it's not good at, well, cooling a case or something like that. But in a radiator type application, it matters a lot less because the idea is to fill the space with air and the air will naturally kind of push through it by pressure. Or if you have the fan on the reverse side and you're pulling it, it doesn't matter that the fan is spewing the air in every direction because the air is still being pulled through the radiator or heatsink. So I personally just view this as a scientific test and not quite as applicable to, well, PC cooling. But how does it do? Well, it's very similar to my control fan, which lines up pretty well for the CPU cooler test. And as for noise versus CFM, we can see that it is a terrible choice. It is very noisy for the amount of air that it pushes. But continuing to CFM real quick, how does it rank in noise normalized testing? Well, it's towards the bottom of the pack. Right there, the TLG12 is just underneath it. The NF P12 Redux is doing slightly better than it, and it's substantially further away than the top performers. At 100% PWM fan signaling, it is right towards the top. However, in this test, it is not at the top. Notes about the data, fan name, RPM, and the noise level, and the air speeds, or CFM, are all listed at the end of each of the graphs. So here, the Iceberg Thermal Xtra is not the top performer, but it's still ranked well up there, just not as good as, well, some of the other fans. And last, certainly but not least, for CFM testing, it's CFM versus decibel readings. And the Iceberg Thermal is this dark blue line listed right there. and here it's basically at the bottom of the pack. It's not good. Well, let's do our open box experience and do our fan analysis, and then we'll talk about its value proposition. Now that we've finished taking a look at the graphs, let's go over our open box experience. So it comes with this basic brown packaging. On the back, it's got some basic spec information, voltage, and the amperage. It does require 0.5 amps, which is a pretty substantial amount. So you can't daisy chain these fans together. You would probably blow out the fan header on your motherboard. So take that as a note. When selecting this fan, it goes from 500 to 3000 RPM listed. Dual ball bearing, standard thickness, it's CFM, decibel reading, millimeters of H2O. And we saw this, or I went through all this in my testing. In the box, we get this nice covering that actually covered the fan, and we get some very basic unpainted screws. Now let's zoom in and take a closer look at this fan. So first, I want to talk about the frame. This frame design does not lead itself to pressure applications. First and foremost, 100%. It does not have a nice box seal. It's got a bunch of little angles on it, and it just won't seal up as nicely as a standard, just a box frame design. So it potentially will have air gaps that air can seep out around it when using on a radiator. However, on a heatsink, it should do okay. Because heatsinks are less of a pressure application and sort of a hybrid between pressure and airflow. It's just the difference between like fin density. Taking a look at the back, we can see that the struts holding in place are fairly substantial in thickness, which does restrict airflow to some extent, and the design of them is fairly basic overall. They have enough of an angle and sweep on them that they're helping guide the air, but overall it's just not overly impressive, I guess. So while I'm here talking about this fan, I want to go over a couple notable notes. Case airflow on it was okay to good. Obviously, you can go to 3000 RPM and just force its way to the top. So I'm talking noise normalized type performance. Heatsink airflow, RPM versus speed was good. Noise was okay to good. The main issue I had with this fan was the motor. At constant PWM signaling, I could hear the fan speeding up and slowing down pretty much constantly. The motor would just cycle itself. So that noise fluctuation that you'd hear is very apparent to the human ear. So it'd be like, woo, woo, woo. So I would find that very unpleasant personally. If you can put up with it, then it is, I guess, just fine. Also in the Windows operating system, the fan just did not work. While in the BIOS, it would read just fine. I could adjust the PWM signaling, and I could do my testing on the fan. But once in Windows, the fan would automatically just shut off no matter what PWM signal I would apply to it. So I'm not sure what's going on, but I have some quality control concerns over this fan itself. I did read Amazon reviews that where people did not seem to have the same problem as me, so it's just kind of buyer beware. It could also just because that I use extension cables to get the fans out of my case to do the testing, and got some power drop loss across the cables, but I feel it's kind of unlikely. Now let's go specifically into the fan blade design, and I wanted to bring up a fan blade that I thought was fairly similar in design, and this is the fan that came in my Synology NAS. You'll notice a very similar sort of swervy shape, although this has a little bit of a different end tip. But I just thought that was kind of interesting, which is why I brought it out temporarily. So this fan blade is fairly unique from all the other ones that I've taken a look at right now. It comes in, sweeps out, comes back, and curved. And basically that change in shape is an aerodynamic profile, but its actual effect I can't do without doing a computer simulated design to see exactly what it's doing. But these curved shapes do adjust aerodynamics and how the air flows over it. In terms of the features on the bottom, this is fairly smooth, although you get a very pronounced cup shape right here in the middle, where you have this changeover to that swerve. And these tips are very, very sharp. The front blade is sharp and then ends in a very sharp point, I accidentally stuck my finger in there and got a nice little poke on it. So just be careful. Sorry, I just sneezed there for a second. So the central rotor on this one is very big. It honestly looks bigger than on the A12X25, which I've just brought out appearance. Maybe the same size, although it visually looks a little bit bigger. So having a bigger rotor does have the advantage of being able to fit a stronger motor inside, but it does reduce how much blade you have for pushing air through it. Of course, most of the air generated for a computer fan is around the tip as opposed to the middle, because that's where the blades are traveling the fastest. This fan does come in a couple different colors. It has a green color. I just ended up getting the gray color. So you can suit your preference based on what kind of color theme you want. You can, as well as has a little window in the back, you can watch the sleeve bearing kind of rotate around and around and around. The blade design, I think, is very interesting. It obviously performs fairly well in a bunch of tests, but I just can't recommend it based on the results I had when trying to plug it in and get it to work with my motherboard. It was just not a good experience using it. So let's go ahead and jump to the value proposition of the fan to determine whether or not it's a good choice for you. This is the value proposition. So how can you use this data? Well, the value proposition, if you're on a very tight budget, like very tight budget, as in budget is everything to you, that's when you would use this data 100% specifically, because you want the best fan for your money. But let's say you have a little bit of extra money and you're wanting to find the best overall performance, that's including noise, to higher quality fan and get a little bit of extra with it. Like, oh, I don't know. Like, should you spend money on the A12X25, for example, seeing how it's quite a bit off the TLG12? Well, that's when you would use my data in conjunction with this value proposition, which is airspeed or whatever unit of air movement divided by dollars, and you decide what ratio is. And if you've got an unlimited budget, I'm not sure why you're looking at this, because you would just get whichever fan you want, no matter how much it costs. So now that that explanation is out of the way, how expensive is the Iceberg Xtra 120? Well, it's a $20 fan. So in noise normalized values, it is kind of middle-ish, I would say. A little bit below the top dogs, but kind of middle-ish. At its 100% PWM fan signaling, which you should never be running your case fans at. Please don't. It means something has gone terribly wrong in your case. It ranks fairly well because it just is able to push so much air. But the top performer here is still the TLG12, and it's been there for quite some time since I reviewed it. The Antec Storms rank fairly well, but they tend to drop off at the 100% PWM fan signaling mark, and the Arctic P12 does fairly well here as well. Moving on to the 11-inch mark in the case test. How does it rank? Well, once again, it's still sort of in that middle area, and it's lost quite a bit of ground, although a lot of other fans have dropped off as well at that 11-inch mark. So it really shouldn't be considered for bigger cases. And as for how it performs in a CPU cooler at type application, so its value in the CPU cooler, it is ranked very, 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 very well. So just a little bit worse than TLG12. The Wonder Snail is right next to it in terms of performance, but the top performers here for noise normalized values are the Antec Storm series. They perform particularly well here. At 100% PWM fan signaling, well, the Arctic P12 ranks really well. It is the top performer now. The TLG12 is still a great value proposition overall. And the the Antecs are still doing pretty well. They're about equal to the Iceberg Xtra 120. And I do want to note, I forgot to say this earlier, the Iceberg does have a version that is a slower RPM, and if you're curious how it performs, you can just use the data and see what RPM it runs at maximum, and just get whichever one kind of suits your needs and your budget. And as for its value proposition in CFM testing, well, here it's well off from the middle. I would say it's actually towards the low side, and even at its 100% PWM signaling mark, it's really not there. So that brings me to the conclusion of this fan. I would say it's okay, but there are better fans out there. So I think its blade design looks interesting. It's got two color palettes, gray and green, but there are a couple major issues with it. One, it didn't work for me in Windows. You may have a different experience than me. Two, it has a ridiculously high amperage. It could be that it wasn't working because I have to use a couple extender cables just to get out of the case for my testing. So I could have had just enough losses in those cables that it just didn't function. Or you may need to use the header on your motherboard for the like AIO pump or water cooling pump in order to power this thing. So those are my areas of hesitation for it. Its overall build quality felt fine. The blade design was interesting. Its value is kind of there, depending on what you're using for. I wouldn't get it for a case fan. If you want something for a CPU cooler, it's okay. And well, I guess that's it. Next up, I'm gonna show you the raw data. Thank you very much for watching my video. Please subscribe for more content. Please check out my Patreon page. If you have any suggestions for fans that I should do in the future, please leave it in the comment sections down below. And have a great day. I'll see you next time. Alright, this is the raw data for the IceGale Iceberg Thermal Xtra 120. Again, it does have a second version, as well as in a couple different colors, and it's got a 140mm version. That'll be in another video. But this is the raw data. If you want to use it for your own purposes, you are more than welcome to record it for yourself and create these graphs for yourself. However, I do ask that if you use it in a publication, you give me credit, because I spent a lot of time and effort putting all this together. It takes me a solid hour and a half just to do testing at these data points. It also takes quite a bit of time to update graphs and, well, make PowerPoints and then record the video. But at this time, I also want to thank you for watching my video. I have a Patreon page. Please check it out. Subscribe for more content. And if there are any fans that you want to see me review in the future, please, please, please leave it in the comment section down below. I read every comment and I try replying back, giving my thoughts, feedback. What if you have constructive criticism on ways that I can improve my video, please go ahead and leave it down below. Other than that, I appreciate every single one of you who watches my videos, and I hope to see you next time here on Computer Tech and More.